Hello, and welcome back to the quiet space of knowledge before sleep. The night is late, all things are sinking into a deep slumber, and this is also the time when our minds need to be set free, to leave behind the worries of the day and embark on a wondrous journey. Tonight, I want to invite you to join me on the farthest journey humanity has ever undertaken. We will not travel with our feet, but with our imagination, to follow the silhouettes of two small emissaries silently crossing the vast darkness of the universe. This is the story of the Voyager probes, the most distant human-made objects, telling us about the undisclosed mysteries at the edge of our solar system. Find a comfortable position, take a deep breath, exhale slowly, and let my voice guide you into the silent space between the stars. Right now, as you lie relaxing and listening to these words, a small object, only about the size of a compact car, is on an extraordinary journey. It's moving at a speed we can hardly imagine, over 17 kilometers per second. Picture a velocity so fast that in the blink of an eye, it has traveled a distance longer than an entire city. That object is traversing through a deep void, a place so cold and dark that the sun's light no longer has the strength to warm it. That craft is named Voyager 1. Currently, it is an unimaginable distance from our Earth, 24 billion kilometers. To help you better visualize this vastness, imagine you are driving a car on an endless highway and you never stop. Even if you drove continuously day and night at the maximum allowed speed, it would take you more than 27,000 years to reach the place where Voyager 1 is right now. 27,000 years, a period of time many times longer than the entire history of our human civilization. The most extraordinary thing here isn't just that distant expanse. What astounds us is that this tiny craft is still diligently carrying on with its work. Amidst the vast and silent space, it still regularly sends signals back to us. These signals travel at the speed of light, the fastest speed in the universe. But because the distance is so great, they take more than 22 hours to reach Earth. Each message Voyager 1 sends is like a whisper from the past, carrying stories of a world beyond our understanding. What those signals have told scientists has challenged almost everything we thought we knew about the universe. Voyager 1 has traveled farther than any human-made object has ever reached before. It has passed beyond Neptune, the last planet in our solar system, to enter a territory we weren't even sure existed. It is the frontier of interstellar space, where the solar wind begins to recede before the encroachment of the galactic night. In the absolute silence of the dark night, the craft flies on quietly, without a sound. It needs no roaring engines, no brilliant sails. It simply glides through the vacuum, carrying with it humanity's thirst for knowledge. Voyager 1, along with its twin sister Voyager 2, was originally designed to operate for a mere 4 years, but miraculously, they have been functioning for 46 years and have yet to stop. The information they are sending back from the very edge of the solar system is not only surprising to the scientific community, but in many ways, it cannot be explained by our current models of knowledge. Every step Voyager takes in space is another time we must rewrite the pages of astronomy textbooks. They show that the universe out there is far more complex than the silent pictures in a telescope. It is vibrant and dynamic in ways we never expected. As you listen to this, feel the peace spreading through you. Out there, where darkness reigns, Voyager is still protecting fragments of Earth's memories. It carries a gold-plated copper disc, which contains the sounds of ocean waves, the blowing wind, the beat of a human heart, and the magnificent music of geniuses like Beethoven and Mozart. That disc is like a love letter we've sent into the cosmos, with the hope that someday, millions of years from now, someone will find it and understand that we once existed, that we loved, and that we yearned to explore. The journey of Voyager is not just a dry scientific mission. It is a message of humanity's extraordinary optimism. It is a declaration that we, though living on a tiny pale blue dot in an ocean of space, still have the courage to reach for the farthest stars. Tonight, Voyager will continue to fly, and you too should let your mind drift just like that. For a moment, forget the dry numbers, and just remember that in a place very far away, a small friend of ours is quietly telling stories to the galaxy. To understand the greatness of the journey the two Voyager probes are on, we need to go back in time more than 46 years. Those were the years of the 1970s, a time when humanity truly began to yearn to know what lay in the dark peripheries of the solar system. Back then, distant planets like Uranus and Neptune were just faint, mysterious specks of light that even the most powerful telescopes on Earth couldn't see clearly. The story begins at a sun-drenched launch site at Cape Canaveral, Florida. In the summer of 1977, the whole world held its breath, watching the birth of an ambitious project. Two spacecraft, named Voyager 1 and Voyager 2, were ready to leave the launch pad. There's an interesting detail that few notice, which is that Voyager 2 was actually launched first, on August 20th, 1977. Meanwhile, its sister craft, Voyager 1, didn't begin its journey until September 16th. Why was the order reversed like that? It was a brilliantly scientific calculation. Voyager 1 was launched later, but traveled on a shorter and faster trajectory, allowing it to overtake its sister craft to reach Jupiter and Saturn sooner. From the very beginning, the two probes carried separate but perfectly complementary missions, like two explorers entering a strange forest but choosing different paths so as not to miss any wonders. When the giant flames from the booster rockets blazed and lifted the two probes out of Earth's atmosphere, humanity sent with them all the finest technology of that era. Imagine, the computer on board Voyager had millions of times less memory than the smartphone you're holding in your hand today. Even the electronic key fob for a modern car has more computing power than the control system of the craft that is now crossing the galaxy. Yet, with that rudimentary equipment, NASA scientists created a miracle that no modern device has been able to replace to this day. At that time, the energy source to sustain the two probes was not brilliant solar panels. As they ventured deep into distant space, the light from the sun would become too faint to provide electricity. Therefore, the designers equipped them with nuclear generators that use heat from the decay of plutonium pellets. These tiny nuclear hearts have been quietly burning for the past 46 years, providing power for the cameras, sensors, and communication systems, ensuring Voyager never loses connection with its home. Immediately after leaving Earth, the first and greatest challenge to human patience was the distance. To get from Earth to the first planet on its exploration list, Jupiter, the two probes had to spend nearly 2 long years flying in solitude. During that time, engineers on the ground had to be on constant watch, adjusting the slightest angle of the antennas to ensure the signal wouldn't get lost in the void. That feeling of waiting was like sending a letter far away and having to wait months or even years for a reply. But every signal that came back from Voyager in those early days brought overwhelming joy. They confirmed that the craft was fine, the systems were operating well, and they were getting closer than ever to giant, stormy worlds. Launching two probes at the same time wasn't just for redundancy in case of failure. It was a strategy to broaden humanity's horizons. While Voyager 1 was programmed to prioritize exploring Jupiter, Saturn, and then the mysterious moon Titan, Voyager 2 shouldered a longer-term mission. It would use the gravity of the planets to slingshot itself, continuing to the very edge of the solar system to meet Uranus and Neptune. As you lie here, try to imagine the silence that the two probes experienced in the first years of their journey. After escaping Earth's gravity, they glided through space without any resistance, in a perfect vacuum. There was no sound of wind, No engine noise, only an enchanting silence. The Voyagers were not just machines, they were pioneers, carrying the pride and infinite curiosity of a small but ambitious species. The beginning of Voyager was like the small step of a child just learning to walk. But that step was heading toward the vast ocean of the cosmos. Those early days laid the foundation for all the shocking discoveries that followed, things that completely changed our understanding of our neighbors in the solar system. The story of this hopeful beginning closes to make way for even greater wonders. In the next chapter, I will tell you about a serendipitous arrangement of nature, a once-in-a-millennium opportunity that allowed humanity to undertake this great journey within a single lifetime. It is a secret of mathematics and orbits that, without it, we might never have reached those distant planets. Just let your mind drift gently along Voyager's path, and we will meet again in the following pages of this journey of 1,000 miles. For a spacecraft to travel to the distant frontiers of the solar system, courage and the most powerful rockets alone are not enough. The universe is much vaster than we imagine, and burning fuel to cross billions of kilometers is an incredibly daunting economic and engineering problem. Yet, in the 1960s, a young engineer at NASA's Jet Propulsion Laboratory named Gary Flandreau happened to discover something extraordinary, an astronomical event that occurs only once every few hundred years. While performing calculations for orbits to the outer planets, he realized that in the late 1970s, the four giants of the solar system, Jupiter, Saturn, Uranus, and Neptune would align in a special configuration. This alignment is so rare that it occurs on average only once every 175 years. The last time these planets were in a similar position was when Thomas Jefferson was President of the United States, a time when humans still traveled by horse and sail. This arrangement opened a magical door for space exploration. It allowed scientists to use a sophisticated technique called a gravity assist. Imagine the Voyager spacecraft as a marble thrown into a whirlpool. As it approaches a giant planet like Jupiter, the planet's immense gravity pulls the spacecraft in, accelerates it, and slingshots it toward the next planet at a much greater speed. This is like a push from the universe itself, helping the spacecraft travel farther and faster without using a single extra drop of fuel. Without this leapfrogging technique, thanks to gravity, reaching Neptune would have required decades more of continuous travel. However, even though nature was ready to help, humanity still faced another barrier: money. The original project, called the Grand Tour, was slated to build 4 massive spacecraft with the most advanced technology to undertake a great tour of the planets. But its budget was a colossal figure that the United States Congress refused to approve. The scientists of that time watched as the opportunity of a century seemed to slip through their fingers. Yet, with a burning passion, they did not give up. They quietly proposed a smaller, more modest version, consisting of only 2 spacecraft with the humble goal of visiting Jupiter and Saturn to receive financial approval. However, there was one thing that everyone at NASA knew, but no one publicly acknowledged at the time. These spacecraft were secretly designed with durability and capabilities far exceeding their initial objective. They were prepared, if all went well, to continue their journey even further, through the darkness to unknown worlds. Each Voyager spacecraft weighs about 825 kilograms and carries 10 different scientific instruments. These included cameras capable of photographing moons from millions of kilometers away, atmospheric analysis devices, and magnetometers. Every detail on the craft was calculated to withstand the harshness of the space environment for decades. As you sink deeper into relaxation, think about this wonderful combination: a chance alignment of planetary orbits from millions of years ago, combined with human intellect and perseverance. Voyager is not just a product of technology, it is also a product of faith. The scientists believed that we could reach farther than what was permitted. that we could harness the power of the universe itself to explore it. That once-in-a-millennium opportunity was fully seized. The two spacecraft set off, gliding on invisible gravitational waves, carrying with them not only dry measuring instruments, but also another precious treasure for anyone who might find them later. In the next chapter, we will explore that treasure, a golden record carrying the soul and voice of all humanity, drifting among the myriad stars. But for now, let your mind rest in the silence of space, where every movement is as gentle and smooth as a deep dream. When the two Voyager spacecraft left their home, they didn't just carry dry electronics or state-of-the-art cameras. Tucked silently on the side of each craft was a special treasure, an object representing the most extraordinary act of optimism of our human species. It was the gold-plated record, often called the Voyager Golden Record. Imagine an object capable of outlasting even our greatest constructions. Scientists have calculated that these records, made of gold-plated copper and protected in an aluminum case, could remain readable for the next 1 billion years, or perhaps even longer. 1 billion years is a period of time in which even our most steadfast pyramids or magnificent cathedrals will have crumbled and turned to fine dust eons ago. But in the vastness of space, the golden record will still be there, intact, carrying the breath of a civilization that once existed. Inside that record is an entire miniature world, meticulously encoded. Scientists selected 116 images representing life and culture on Earth. There are images of children, roads, architectural structures, and the beauty of wild nature. Following that are the warmest greetings in 55 different human languages, from ancient languages like Hebrew to modern tongues like Polish and even the Wu dialect, all join in a single message of peace sent into the cosmos. But perhaps the most moving part of this treasure is the music. 90 minutes of music were carefully selected to tell the story of the human soul. There, you can find the classic melodies of masters like Bach, Beethoven, or Mozart. But that's not all. The music of Voyager is also rich with the spirit of diverse cultures from across the planet. From the songs of the Pygmy people in Africa, the traditional music of Azerbaijan, to the soulful songs of the Navajo Indians, and the fiery rock and roll tunes of Chuck Berry. Besides the music and voices, the record also preserves the primordial sounds of Earth, the sound of wind rustling through leaves, the sound of ocean waves lapping against the sandy shore, and even the beat of a human heart in love. All were sent with official messages from the Secretary General of the United Nations and the then President of the United States, Jimmy Carter. The person primarily responsible for selecting this precious content was the astronomer Carl Sagan. When asked if it wasn't too naive to think that some alien civilization might find these tiny spacecraft in the infinite vastness of the universe, he replied with a meaningful smile. Sagan understood that this record was not merely a message for extraterrestrials. First and foremost, it was a message for ourselves. It is a proud declaration that we are a species capable of thinking about the distant future, a species that can imagine its music and voices will still exist long after all who created them have vanished from this world. The golden record is like a symbol of a fragile but real immortality. It proves that despite our flaws, our wars, or our cruelty, humanity always contains beauty, curiosity, and an intense desire to connect with the vast universe. As you listen to these words in the quiet space, try to imagine that record gliding through the darkness. It is not alone, for it carries the memory of billions of people who once lived and hoped on our blue planet. It is a love letter we send to the future, to friends in distant galaxies whom we may never meet. The journey of Voyager carrying the soul of Earth continues, but that treasure will have to wait. Because before fulfilling their mission as a technological fossil, the two spacecraft had important scientific objectives to accomplish. The giant planets awaited them with mysteries never before explored. In the next chapter, we will join Voyager 1 as it approaches Jupiter, the gas giant of the solar system, where humanity, for the first time, saw fierce storms and strange moons at a breathtakingly close range. For now, let your heartbeat slow down, steady and even, like the sound recorded on the golden disk flying among the myriad stars. We will meet again when Voyager begins its shocking discoveries in the world of the gods. Sau gần 2 năm ròng rã bay qua khoảng không tĩnh lặng và tối tăm, vào tháng 3 năm 1979, tàu vũ trụ Voyager 1 cuối cùng đã tiếp cận được điểm đến đầu tiên trong hành trình của mình, sao Mộc. Đây là hành tinh lớn nhất trong hệ mặt trời, một gã khổng lồ khí hùng vĩ mà từ lâu con người đã ao ước được chiêm ngưỡng tận mắt. Mặc dù chúng ta đã quan sát sao Mộc trong nhiều thế kỷ bằng những chiếc kính thiên văn ngày càng mạnh mẽ hơn, nhưng những gì mà máy ảnh của Voyager nhìn thấy ở cự ly gần đã khiến các nhà khoa học tại trung tâm điều khiển hoàn toàn lặng người. Hình ảnh đầu tiên hiện ra trước mắt chúng ta chính là vết đỏ lớn, một biểu tượng vĩnh cửu của sao Mộc mà con người có thể nhìn thấy ngay cả từ trái đất. Tuy nhiên, khi nhìn nó qua đôi mắt của Voyager ở khoảng cách gần, thực tế lại là một câu chuyện hoàn toàn khác. Vết đỏ lớn thực chất là một cơn bão khổng lồ, một xoáy nghịch dữ dội có kích thước lớn đến mức bạn có thể đặt 3 trái đất của chúng ta nằm gọn bên trong nó. Hãy tưởng tượng một cơn bão bao trùm toàn bộ hành tinh xanh của chúng ta, nhưng nó vẫn còn nhỏ hơn nhiều so với mắt bão của sao Mộc. Điều kinh ngạc hơn nữa là cơn bão này không hề tan biến. Nó đã quay liên tục trong ít nhất 300 năm và có thể là còn lâu hơn thế nữa. Trong khi những cơn bão trên trái đất chỉ tồn tại vài ngày hoặc vài tuần, thì trên sao Mộc, thời gian dường như ngưng đọng trong những vòng xoáy bất tận. Khi Voyager một lướt qua bầu khí quyển của hành tinh này, nó đã ghi lại được những dải màu sắc không tưởng, đẹp tựa như một bức tranh sơn dầu khổng lồ đang tan chảy. Đó là những dải mây màu cam rực lửa, màu trắng kem tinh khôi xen lẫn với những vệt màu nâu sẫm bí ẩn. Trước khi Voyager đến đây, các nhà khoa học đã mong đợi sẽ tìm thấy một bầu khí quyển tương đối đơn giản, nhưng những gì họ tìm thấy lại là một hệ thống thời tiết phức tạp đến mức cho đến tận ngày nay chúng ta vẫn chưa thể hiểu hết được toàn bộ cơ chế vận hành của nó trong không gian tĩnh lặng mà con tàu đang di chuyển. Bầu khí quyển của sao Mộc lại là một nơi vô cùng náo nhiệt và dữ dội. Những cơn bão điện tại đây mạnh đến mức khiến cho những cơn bão lớn nhất trên trái đất trở nên thật nhỏ bé và không đáng kể. Voyager đã ghi nhận được những tia sét rạch nát bầu trời sao Mộc với cường độ mạnh hơn hàng nghìn lần so với bất kỳ tia sét nào từng được ghi nhận trên hành tinh của chúng ta. Cùng với đó là những luồng gió thổi không ngừng nghỉ với vận tốc 500 km/h. Bạn hãy thử hình dung về một sức gió mạnh hơn cả những siêu bão cấp cao nhất, nhưng lại duy trì liên tục từ năm này qua năm khác, tạo nên một bản giao hướng trầm hùng và đầy quyền năng của thiên nhiên. Sự choáng ngợp mà sao Mộc mang lại không chỉ dừng lại ở kích thước hay sức mạnh của những cơn bão. Nó còn nằm ở cách mà hành tinh này thách thức mọi hiểu biết cũ kỹ của chúng ta. Mỗi tấm ảnh, mỗi thông số gửi về trái đất vào năm 1979 đó giống như một lần chúng ta mở ra một cánh cửa mới vào vũ trụ. Chúng ta nhận ra rằng những thế giới bên ngoài kia không hề tĩnh lặng hay chết chóc. Chúng sống động, cuồng nhiệt và chứa đựng những nguồn năng lượng mà con người mới chỉ bắt đầu chạm tới lớp vỏ ngoài cùng. Tuy nhiên, đối với các nhà khoa học lúc bấy giờ, sao Mộc chỉ là món khai vị cho một bữa tiệc khám phá còn lớn hơn thế. Điều thực sự mang tính cách mạng và thay đổi hoàn toàn sách giáo khoa về địa chất học không chỉ nằm ở bản thân hành tinh khí này, mà lại đến từ những người bạn đồng hành của nó. Những mặt trăng đang âm thầm quay quanh gã khổng lồ. Khi bạn đang thả lỏng tâm trí theo từng dải mây màu cam và trắng của sao Mộc, hãy cảm nhận sự bình yên của không gian bao la. Con tàu Voyager vẫn lặng lẽ lướt đi, rời xa những cơn bão dữ dội để hướng về phía những mặt trăng kỳ lạ. Ở đó, những bí mật về lửa và nước đang chờ đợi được hé lộ. Những thứ sẽ khiến chúng ta phải nhìn nhận lại về khả năng tồn tại của sự sống ở những nơi xa xôi nhất. Chúng ta sẽ khép lại chuyến tham quan bầu trời sao Mộc tại đây để chuẩn bị bước vào một chương mới đầy kịch tính. Ở chương tiếp theo, tôi sẽ kể cho bạn nghe về Io, một mặt trăng phun trào lửa giữa lòng vũ trụ băng giá, và Europa, một thế giới được bao phủ bởi lớp băng nhẵn mịn, nhưng lại ẩn giấu một đại dương nước lỏng mênh mông bên dưới. Đó là nơi mà những hy vọng về sự sống ngoài trái đất bắt đầu nảy nở một cách rực rỡ nhất. Hãy hít thở thật đều để hình ảnh Vega khổng lồ sao Mộc mờ dần trong tâm trí, nhường chỗ cho sự tĩnh lặng và chuẩn bị cho những khám phá kỳ diệu tiếp theo trong sự tĩnh lặng bao la của vũ trụ. Khi tàu vũ trụ Voyager một tạm biệt gã khổng lồ sao Mộc, nó đã hướng ống kính của mình về phía những vệ tinh đang âm thầm quay quanh hành tinh này. Đó là lúc một trang sử mới của thiên văn học được viết lên, mang theo những phát hiện làm đảo lộn mọi lý thuyết mà con người từng tin tưởng. Chúng ta sẽ cùng nhau khám phá hai thế giới hoàn toàn trái ngược, một nơi rực cháy bởi những ngọn lửa vĩnh cửu và một nơi ẩn giấu đại dương mênh mông dưới lớp vỏ băng giá. Điểm dừng chân đầu tiên là Io, mặt trăng nằm gần sao Mộc nhất. Khi những hình ảnh đầu tiên về Io được gửi về, các kỹ thuật viên hình ảnh tại trái đất đã vô cùng bối rối. Họ thậm chí đang nghĩ rằng có điều gì đó không ổn với thiết bị máy ảnh của con tàu. Họ đã kiểm tra dữ liệu đến 3 lần, điều chỉnh từng thông số nhỏ nhất và phân tích mọi lỗi có thể xảy ra, nhưng không có lỗi nào cả. Những gì họ thấy là hoàn toàn có thật. Io có những ngọn núi lửa đang hoạt động dữ dội. Trước khi Voyager đến nơi, các học thuyết thời bấy giờ đều cho rằng những mặt trăng ở xa mặt trời như thế này sẽ là những thế giới chết chóc, băng giá và không có bất kỳ hoạt động địa chất nào. Nhưng Io đã phá tan những suy nghĩ đó. Chỉ trong một phút chốc, người đầu tiên phát hiện ra điều kỳ diệu này là một nữ kỹ sư dẫn đường tên là Linda Moravito. Trong khi đang xử lý những bức ảnh về các vì sao để xác nhận vị trí của con tàu, cô đã tình cờ thấy một hình bóng lạ lùng ở rìa của Io trên nền không gian đen thẳm. Đó là một khối lồi sáng rực, một cột tro núi lửa khổng lồ đang phun trào ngay tại thời điểm bức ảnh được chụp. Chính cô là người đã báo động cho cả thế giới về hoạt động núi lửa ngoài trái đất đầu tiên được tìm thấy. Những cột vật chất từ núi lửa trên Io phun cao đến hàng trăm km trên bề mặt, mặn đến mức chúng gần như vươn tới không gian bên ngoài. Vậy điều gì đã khiến một mặt trăng nhỏ bé, xa xôi với sức nóng của mặt trời, lại có thể chứa đựng những ngọn lửa mãnh liệt đến thế? Câu trả lời hóa ra lại chính là sao Mộc. Lực hấp dẫn khổng lồ của hành tinh khí này, kết hợp với ảnh hưởng từ các mặt trăng lớn khác xung quanh, đã liên tục kéo giãn và nén ép Io. Quá trình này tạo ra một lực mà sát bên trong vô cùng lớn, sinh ra một lượng nhiệt khổng lồ làm nóng chảy lỏi của Io. Nhờ lượng nhiệt đó mà bề mặt của nó liên tục được làm mới bằng những dòng dung nham tươi mới. Cho đến nay, Io vẫn được ghi nhận là thiên thể có hoạt động núi lửa mạnh nhất trong toàn bộ hệ mặt trời của chúng ta. Rời xa địa ngục rực lửa Io, Voyager đưa chúng ta đến với Europa, một mặt trăng khác của sao Mộc, mang một vẻ đẹp hoàn toàn trái ngược. Europa đặt ra cho các nhà khoa học một bí ẩn khó hiểu không kém. Khi nhìn từ xa, bề mặt của nó nhẵn mịn một cách lạ thường. Thông thường, trên những thế giới không có bầu khí quyển bảo vệ, chúng ta sẽ mong đợi. Thay vào đó, bề mặt của nó được bao phủ bởi những đường kẻ, vết nứt đan chéo vào nhau, trông giống như những đường gân trên nhãn cầu của con người. Điều này dẫn đến một kết luận không thể tránh khỏi: phải có một thứ gì đó liên tục làm mới bề mặt của Europa, xóa đi các hố va chạm và tạo ra những vết nứt mới. Các nhà khoa học nghi ngờ rằng thứ đó chính là nước ở thể lỏng. Bên dưới lớp vỏ băng giá của Europa có thể tồn tại một đại dương toàn cầu mênh mông. Cũng chính lực ma sát hấp dẫn từ sao Mộc đã giúp duy trì đại dương này ở trạng thái ấm nóng, dù nó nằm cách mặt trời đến 800 triệu km. Nếu sự tồn tại của đại dương này là thật, Europa ngay lập tức trở thành một trong những nơi hứa hẹn nhất để tìm kiếm sự sống ngoài trái đất. Chúng ta không nói về những sinh vật thông minh, mà có lẽ là các vi sinh vật nhỏ bé, hoặc thứ gì đó phức tạp hơn một chút, bởi vì nước ở thế lỏng chính là yếu tố cần thiết nhất cho sự sống mà chúng ta biết. Hãy thử tưởng tượng về một đại dương ẩn mình dưới hàng km băng. nơi sự sống có thể đang âm thầm nảy nở giữa lòng không gian lạnh lẽo. Hai thế giới, một bên là lửa rực cháy, một bên là băng giá bao phủ đại dương, đã dạy cho chúng ta một bài học quý giá về sự đa dạng của vũ trụ. Chúng cho thấy rằng, ngay cả ở những nơi khắc nghiệt nhất, năng lượng vẫn luôn hiện hữu dưới những hình thái kỳ diệu nhất. Tàu vũ trụ Voyager đã giúp chúng ta mở màng tầm mắt, để chúng ta hiểu rằng hệ mặt trời của mình chứa đựng nhiều điều bất ngờ hơn bất kỳ trí tưởng tượng nào có thể hình dung. Giờ đây, khi hình ảnh về những ngọn núi lửa trên Io và lớp băng nhẫn mịn của Europa dần mờ đi, hãy để tâm trí bạn được thư giãn hoàn toàn. Chúng ta đã cùng Voyager đi qua những chặng đường đầy kinh ngạc tại sao Mộc. Con tàu vẫn đang tiếp tục hành trình của mình, sử dụng lực hấp dẫn để tăng tốc và hướng về phía một hành tinh rực rỡ khác với những vành đai băng huyền ảo. Trong chương tiếp theo, chúng ta sẽ cùng Voyager một ghé thăm sao Thổ, nơi chúng ta sẽ được chiêm ngưỡng vẻ đẹp lộng lẫy của những vành đai khổng lồ và khám phá những bí ẩn nằm sâu trong bầu khí quyển mờ ảo của mặt trăng Titan. Nhưng lúc này, hãy cứ tận hưởng sự yên bình của không gian, để những hơi thở thật nhẹ nhàng đưa bạn vào trạng thái nghỉ ngơi sâu sắc nhất. Leaving the stormy, fiery skies of Jupiter, the Voyager 1 spacecraft continued its silent journey through the cold void. In November of 1980, after a long, arduous journey, it reached Saturn, the planet of the most vibrant and magnificent rings in the solar family. Once again, surprises abounded, completely changing the way we perceive the beauty of the cosmos. For centuries, humans have been captivated by the rings encircling this planet. In the year 1610, when the astronomer Galileo first looked through his crude telescope, he was utterly bewildered. He didn't know how to explain what he saw and described them as large ears on either side of the planet. Through generations, astronomers studied Saturn with increasingly modern telescopes. They learned that the rings were composed mainly of ice. They also knew that they seemed to be divided into several main sections, separated by large, seemingly empty gaps. But the truth Voyager revealed was far more complex and wondrous than that. As Voyager 1 drew near, its camera lenses captured a complexity that challenged all prior human understanding. What we once thought were a few wide bands were actually made up of thousands of individual ringlets. Thousands of tiny rings, each with its own unique composition, its own density, and its own story. Imagine a colossal symphony composed of countless sparkling ice crystals, each crystal like a musical note, gracefully revolving around its parent planet. The images sent back from Voyager showed a beauty both pristine and mysterious. There were braided rings that looked as if they were twisted together like ropes. There were also ripples and gentle curves caused by the gravitational influence of tiny shepherd moons. These moons are like diligent housekeepers, using their gravity to keep the ice particles in place, maintaining the perfect shape of the rings. However, what puzzled scientists the most was the appearance of dark spokes on the rings. These dark streaks appeared and disappeared strangely, moving in ways that seemed to violate the simple laws of orbital mechanics. They formed and dissipated in just a few short hours. They did not orbit Saturn as any normal matter trapped in the rings should. Instead, they moved almost as if they were suspended by some force other than gravity. The most widely accepted explanation today involves the power of electromagnetic fields. It is these electric fields that lifted fine dust particles above the plane of the rings, creating images resembling the spokes of a giant wheel. Yet, even after more than 4 decades of dedicated research, the mysterious spokes of Saturn's rings have never been fully explained. They remain there, shimmering and hiding electromagnetic secrets in the heart of space. While mesmerized by the dance of the ice rings, Voyager 1 also turned its attention toward Titan, Saturn's largest moon. Titan is truly a giant world, so large it surpasses the size of Mercury. But what makes Titan a prime target of the mission is its atmosphere. It is the only moon in the entire solar system to possess a truly dense atmosphere. The pressure on Titan's surface is even 1.5 times the atmospheric pressure of our Earth. When Voyager 1 approached Titan in 1980, humanity's expectations were immense. We had hoped to see through the hazy fog, to glimpse what lay beneath the surface of this moon. But Titan's atmosphere was too opaque. It was completely impenetrable to Voyager's cameras. All the spacecraft recorded was a uniform orange sphere, with no prominent surface features. A photochemical haze, formed from complex hydrocarbon compounds, enveloped this entire world. Despite a little disappointment at not being able to see the surface, the discovery of an atmosphere full of organic compounds and carbon molecules thrilled the scientists. Those are the very ingredients that, on Earth, we always associate with life. Titan immediately became a giant chemical laboratory, where the secrets of the origin of life might be stored. It would take many decades, thanks to the Cassini-Huygens mission, for us to learn that beneath those orange clouds lie lakes and seas of liquid methane with a strange weather cycle similar to Earth's. The close flyby of Titan came at a great cost for Voyager 1. To study this moon closely, the spacecraft had to follow a trajectory that took it out of the common plane of the solar system. After leaving Saturn, Voyager 1 would have no more opportunities to visit another planet. Its path now only led upward and outward, heading into the vast darkness of interstellar space. Voyager 1's planetary exploration mission officially ended here, but its true journey had only just begun. Breathe gently and feel the serenity as you picture the Voyager 1 spacecraft quietly moving away from the brilliant ice rings. It is flying higher, farther, carrying priceless knowledge about a beautiful, frozen world. Meanwhile, its sister craft, Voyager 2, continues its journey within the solar system's plane, heading towards other giant friends waiting ahead. In the next chapter, we will dedicate our time entirely to Titan, the hazy world of hope and the historic choices that shaped the fates of the two Voyager spacecraft. We will delve deeper into the mysterious orange atmosphere and why it is so crucial to our understanding of the universe. For now, let your mind drift among the sparkling ice crystals of Saturn, feeling the absolute peace of an eternal journey. In the silent, cold expanse of the outer solar system, the moon Titan appears as a huge, captivating question mark for scientists. Titan is Saturn's largest moon, a world so majestic that its size even surpasses that of Mercury. But what makes Titan unique in the entire solar system is not just its size, but something no other moon possesses: a real and incredibly dense atmosphere. In November of 1980, as the Voyager 1 spacecraft headed toward this moon, humanity's expectations were at their peak. Scientists had dreamed of being able to see through the enveloping veil of haze, to admire what lay deep beneath its surface. Imagine a heavy atmosphere, where the surface pressure is 1.5 times that of the atmosphere on our Earth. This wasn't a dead rock in space, but a world with breath, a place holding infinite chemical potential for life. However, as Voyager 1 drew near, it encountered a wall of hazy fog. Titan's atmosphere was completely opaque to the spacecraft's cameras. Instead of rivers or mountains, what the craft recorded was just a uniform orange sphere, with no prominent features visible on its surface. It was a haze formed from complex hydrocarbon compounds, the result of magical chemical reactions taking place in the faint sunlight. Although the initial disappointment of not seeing the surface was real, this discovery opened up a new treasure trove of knowledge. That atmosphere was full of carbon molecules, the basic building blocks that, on Earth, we always associate with life. Titan immediately became a top priority for astrobiology, a giant chemical laboratory waiting to be deciphered. It would take many decades, thanks to subsequent missions like Cassini-Huygens, for us to learn that beneath those orange clouds is a dynamic world with lakes and seas of liquid methane and rain and weather cycles similar to Earth's, but driven by hydrocarbons instead of water. However, this encounter with Titan required Voyager 1 to make an enormous sacrifice. In order to study this moon at a close enough range, engineers had to program the spacecraft to follow a special trajectory. This trajectory was like a fateful turn. It sent Voyager 1 up and out of the plane of the solar system, where most of the planets orbit the Sun. This choice meant that after passing Titan, Voyager 1 would be unable to visit any other planets. It had chosen to leave the family of planets to enter a strange and empty region of space, beginning a solitary journey out into the interstellar space between the stars. The planetary exploration mission of Voyager 1 officially ended here, but that ending was the beginning of its most extraordinary chapter, a journey into the eternity of the galaxy. While its sibling, Voyager 1, began its steep climb to escape the solar system, Voyager 2 quietly followed a different route. After its encounter with Saturn in August of 1981, controllers skillfully kept Voyager 2's trajectory within the plane of the solar system. There were still more distant worlds awaiting it, cold blue planets at the farthest frontier that no human hand or eye had ever seen up close. Take a gentle breath and feel the silence of the two spacecraft as they part ways at different crossroads of the universe. One craft headed toward the deep darkness of the galaxy, carrying with it memories of Titan's hazy orange glow. The other persevered, continuing its journey to seek out the remaining giants in the dark. Voyager 1's sacrifice to study Titan taught us that in the vast cosmos, there are places that, though hazy, hold the promise of life. And Voyager 2's persistence reminds us that the journey of discovery will never end, as long as we still yearn to know what lies beyond the horizon. This chapter concludes as Voyager 1 begins the long, silent years of its journey out of the solar system. In the next chapter, we will join Voyager 2 as it continues its adventure to Uranus, an ice giant with strange features never seen before, a planet lying tilted and lonely in the cold expanse of space. Imagine you are floating in a deep black expanse of space, where the sunlight is just a tiny, faint speck. In January of 1986, nearly 10 years after leaving Earth, the Voyager 2 spacecraft approached a mysterious world named Uranus. This is the seventh planet in the solar system, an ice giant that was accidentally discovered by astronomer William Herschel more than 200 years earlier. The first thing that makes you feel at peace when gazing at Uranus through Voyager 2's lens is its color. Unlike stormy Jupiter or the brilliantly ringed Saturn, Uranus is cloaked in a pale, pure, and soothing blue. As the spacecraft drew closer, scientists eagerly searched for bands of clouds or violent storms, but they found very few signs of turmoil. Uranus appeared incredibly serene, almost a meteorologically sleeping world. It was like a giant, frozen gas ball, gently floating in a vacuum, bringing an absolute sense of tranquility. However, behind that serene tranquility lies one of the strangest mysteries in the universe. Uranus does not spin like a top, as Earth and other planets do. It is tilted to an extreme degree. The planet's axis of rotation is tilted at 98 degrees, causing it to be almost completely flipped on its side. Instead of spinning, Uranus is actually rolling around the Sun like a ball on a lawn. Scientists believe that billions of years ago, a massive object the size of Earth or larger slammed into Uranus with such force that it was permanently knocked over. Even so, that remains just a theory, and this bizarre tilt is still a puzzle without a complete solution. This strange tilt has created the most extreme seasons in the entire solar system. Imagine a summer that lasts for an incredibly long time, where one pole of the planet points directly at the Sun and receives continuous light for 42 Earth years. Meanwhile, the other pole is plunged into complete, deep darkness for that same amount of time. When Voyager 2 arrived, It had the opportunity to study the planet's south pole in unprecedented detail. Not only is its axis of rotation tilted, but Uranus's magnetic field also astonished scientists with its stubbornness. On Earth, the magnetic field originates from near the core and is almost aligned with the rotational axis. But on Uranus, the magnetic axis is tilted 59 degrees from the rotational axis, and, more importantly, it does not pass through the planet's center. It is offset to one side by a distance equal to 1/3 of the planet's radius. It's as if someone placed a bar magnet inside this giant sphere, but placed it crookedly and off-center. This does not fit any scientific model that humans have ever constructed, suggesting that something very strange is happening deep inside this icy world. Moving away from the parent planet, Voyager 2 visited the moons of Uranus, and each one was a work of natural art. The most notable was Miranda, the smallest of the 5 main moons. Miranda's surface looks like an unfinished jigsaw puzzle, with completely different pieces of terrain randomly pasted together. There are cliffs up to 20 kilometers high, much taller than our Mount Everest, situated next to deep canyons and smooth plains. Some believe that Miranda was once shattered into many pieces by a collision and was then pulled back together by gravity in a chaotic jumble. Other moons, like Ariel and Titania, also show scars of past geological activity, proving that they are not just lifeless rocks, but have had a tumultuous history. Voyager 2's encounter with Uranus was incredibly brief. It had a mere 6 hours at its closest approach to capture all of these precious images and measurements. 6 hours to explore an entire planetary system that would likely not have another visitor for many decades to come. Every second, every minute was fully utilized by the engineers, because each image was the treasure of a generation. As those 6 hours passed, the spacecraft continued its plunge into the infinite void. Ahead of it lay one final rendezvous, a deep blue planet at the most distant reaches of the Sun's kingdom. Neptune was waiting at a distance of nearly 4 billion kilometers, where the sunlight is 900 times fainter than what we feel on Earth. Let your mind relax to the rhythm of Voyager 2's flight. Together, we have witnessed the serene, pale blue beauty and the tilted mysteries of Uranus. Now, take a gentle breath, feel the tranquility spread, and prepare for the journey to the place where the winds howl at the very edge of the solar system. The story of Uranus concludes, leaving behind puzzles about its magnetic field and the giant cliffs on its moon, Miranda. We will soon meet Neptune in the next chapter, where the most violent storms await discovery. After bidding farewell to Uranus, the Voyager 2 spacecraft continued to hurtle through the deep darkness of the universe toward the final planet in our solar system, Neptune. At this point, the spacecraft was nearly 4 billion kilometers away from the Sun. At such a vast distance, the sunlight becomes unusually faint, 900 times dimmer than what we see on Earth every day. Communicating with Voyager 2 at this point became an immense test of patience. A signal sent from Earth would take more than 4 hours to reach the spacecraft, and it would take just as long for a response to return. Thus, every time the engineers asked a question and received an answer, they had to wait for 8 long hours. In that vast expanse, there was no room for any last-minute errors. To be able to capture sharp images in the extremely low light conditions at Neptune, engineers had to develop a highly sophisticated technique called image motion compensation. Imagine you are in a car, speeding along at 70,000 kilometers per hour and trying to take a picture of a stationary object on the side of the road without it being blurry. To do this, Voyager 2's thrusters had to rotate the spacecraft with extreme precision during the exposure to keep the image stable, and that effort paid off handsomely. When the first images came back, Neptune appeared in stark contrast to its quiet neighbor, Uranus. This was a world seething with activity, a giant dark storm, which scientists named the Great Dark Spot, dominated the planet's entire southern hemisphere. This storm was so large that it could have swallowed the entire Earth. Around its edges, winds howled at speeds of up to 2,000 kilometers per hour. These are the fastest winds ever measured on any planet in our solar system. Dotted against Neptune's deep blue background were bright white clouds, which looked like cirrus clouds on Earth, but were actually made of frozen methane crystals. These clouds formed and dissipated very quickly, in just a matter of a few short hours. The question arose: why could a planet so far from the Sun, which receives very little energy, generate such violent storms? While Uranus, which is closer to the Sun, is nearly inert, Neptune is a meteorological mess. The answer lies deep within the planet's core. Neptune radiates more than twice the amount of energy than it receives from the Sun. Scientists believe that the slow contraction of the planet under the force of gravity over millennia has released this enormous internal heat source, driving its atmosphere to violent activity. Model: when studying Neptune's magnetic field, Voyager 2 found a strange similarity to Uranus's. Its magnetic axis was heavily tilted relative to its rotational axis and was also significantly offset from the center. This discovery refuted the hypothesis that Uranus's bizarre magnetic field was caused by that planet's tilt. Two very different planets shared a magnetic anomaly, which suggested that human models of how planets generate magnetic fields were still deeply flawed. However, the real star of this encounter was the moon Triton. Triton is Neptune's largest moon, and it is an extremely peculiar world. It orbits the planet in a retrograde path that is opposite to the planet's own rotation and that of most other large celestial bodies. This means that Triton was not born with Neptune, but was a captured outsider. From somewhere in the Kuiper Belt, Triton ventured too close and was caught by Neptune's gravity in an incredibly violent process. Through the lens of Voyager 2's camera, Triton's surface appeared unlike any other place humans had ever seen. Its terrain looked like the rind of a cantaloupe, full of irregular depressions and ridges. Icy plains made of frozen nitrogen reflected the faint sunlight like giant mirrors. But the biggest surprise was the geysers. Here in this frigid world, Voyager 2 recorded plumes of dark material erupting up to 8 kilometers above Triton's surface. This was not hot water, but eruptions of nitrogen gas, heated by the faint sunlight penetrating the translucent ice and vaporizing the nitrogen buried beneath. With a surface temperature of -235 degrees Celsius, Triton is one of the coldest objects in the solar system. Yet it was still geologically active and even had a thin atmosphere. This discovery completely changed our thinking. Geological activity could exist in even the darkest and coldest of places, not necessarily close to a star. On August 25, 1989, Voyager 2 completed its flyby of Neptune and Triton. This also marked the official end of the planetary exploration phase of the Voyager mission. Over the course of 12 years, the two spacecraft had explored 4 giant planets, photographed dozens of moons, and discovered rings, active volcanoes, subsurface oceans, and storms of unimaginable scale. Now, both Voyager probes were together entering truly unknown territory. Their next frontier was no longer a specific planet, but the very edge of the Sun's kingdom. In the next chapter, we will learn about a giant, invisible bubble that protects us from the harshness of the cosmos, the heliosphere, a region the two Voyager spacecraft would have to struggle to cross in order to enter interstellar space. When we talk about the solar system, our minds often immediately picture 8 planets orbiting a brilliant star. However, the solar system is much vaster and stranger than that. Beyond the final planet, Neptune, space stretches on endlessly, with the Kuiper Belt, full of icy objects, and even farther out, the Oort cloud, believed to be the home of billions of comets. But there is something that envelops all of these entities, something invisible to the naked eye, but clearly detected by the Voyager spacecraft's instruments: the heliosphere. The heliosphere can be likened to a giant bubble, the Sun's kingdom within the galaxy. This bubble is created by something very special called the solar wind. Imagine, in addition to emitting light and warmth, the Sun continuously blows out a stream of charged particles, including protons, electrons, and helium nuclei. These particles travel outward at extremely high speeds, up to several hundred kilometers per second. This wind blows in all directions, filling space and pushing back against the interstellar medium, a tenuous gas and dust that fills the void between the stars in our galaxy. Where the solar wind meets the resistance of the interstellar medium, an invisible boundary is formed. This boundary clearly separates our home from true interstellar space. However, determining where this boundary lies was an enormous challenge. Before the Voyager probes approached this region, scientists could only make estimates with vast discrepancies. Some models suggested the boundary was about 100 times the distance from the Earth to the Sun, while other models placed it at 150 times or even further. Our two Voyager spacecraft were heading straight for that invisible boundary. But this journey was not easy, because they were facing a serious problem: time and power. To operate where sunlight could not reach, each spacecraft carried 3 radioisotope thermoelectric generators. These devices convert the heat generated from the decay of plutonium-238 into electricity. At the time of launch, each spacecraft could generate about 470 watts of power, enough to operate all the instruments and computers on board. However, this plutonium decays slowly and unstoppably. With each passing year, Voyager's power supply decreased by about 4 watts. Engineers on Earth knew that a day would come when they would no longer have enough electricity to maintain all operations. They had to start shutting down instruments one by one, beginning with the most power-hungry ones. The biggest question at the time was whether the spacecraft could cross the boundary of the heliosphere before they fell completely silent. While the 2 small spacecraft were gradually disappearing into the void, on Earth, a team of dedicated scientists and engineers at the Jet Propulsion Laboratory persistently monitored every tiny signal. It was a quiet, unglamorous job, but one filled with historical significance. They understood that every day Voyager remained operational was another day humanity gained priceless data from the frontier of the solar system. And then, the data began to get strange. The charged particle detector on board started recording subtle changes. The speed of the solar wind was decreasing. The particles that once moved at 400 kilometers per second were now slowing down, as if they were hitting an invisible wall. This was the pressure from the interstellar medium. Voyager was getting very close to the boundary, but this boundary turned out to be far more complex than we had ever imagined. It wasn't a sharp line, but a chaotic and turbulent region. The signal sent from Voyager took a long time to reach Earth. Imagine, when a piece of data was sent, it had to travel at the speed of light for 22 hours just to reach our antennas. Every piece of information received was a precious puzzle piece of a universe no one had ever seen before. Voyager's journey through the heliosphere was about to enter its most extraordinary phase, a mission it was never designed to undertake, but which would become its most important legacy. It was the moment it would leave the protection of the Sun to truly enter the ocean of interstellar space. Now, as you lie in the warmth and safety of your room, try to imagine the bubble of the heliosphere enveloping us, shielding this planet from the harsh radiation of the distant galaxy. And out there, 2 tiny spacecraft are still flying tirelessly onward, carrying the last warmth of plutonium to tell us about the boundary of our home. In the absolute silence of cosmic night, our 2 small spacecraft continued to press forward, moving away from the warm light of their parent star. Many years had passed since we launched them, and now they stood at a historic threshold, the slow crossing of an invisible border to leave humanity's cosmic home. This journey had no brilliant milestones, only the patience of faint signals traveling across billions of kilometers. In December of 2004, 26 long years after its launch, the Voyager 1 spacecraft reached a position 14 billion kilometers from the Sun. Here, the charged particle instruments on board recorded something extraordinary. The solar wind, a stream of particles that had blown steadily past the planets for decades, suddenly changed dramatically. Its speed dropped sharply, its particle density increased, and its temperature soared. Voyager 1 had officially crossed the termination shock, the region where the solar wind collides with the resistance of the interstellar medium and is violently slowed down. This event marked the first time a human-made object had crossed this boundary, revealing to us a reality far more complex than the theoretical models on paper. The transition was not sharp like a line, but a turbulent, diffuse region. 3 years later, in August of 2007, the Voyager 2 spacecraft also crossed this termination shock at a different distance. This helped scientists realize that the heliosphere, the protective bubble of our solar system, is not a perfect sphere, but is distorted, compressed on one side and elongated on the other, like the tail of a comet. But the moment that truly stirred the heart of humanity was August 25th, 2012. On that day, unbeknownst to anyone on the ground, Voyager 1 officially left the solar system, becoming the first human-made object to enter interstellar space. It took over a year of research and debate for scientists to confirm this monumental event. The reason for this delay was that the final frontier didn't behave as we expected. According to the old models, the magnetic field should have abruptly changed direction as the spacecraft moved from the region controlled by the Sun into the space between the stars. However, the data from August 2012 showed something puzzling. Although the solar wind had completely disappeared and the density of cosmic rays from the galaxy had skyrocketed, the direction of the magnetic field remained unchanged. The debate raged for months among scientists until an unexpected answer came from our own Sun. In March 2012, a powerful coronal mass ejection erupted from the Sun. This wave of energy took more than a year to catch up to Voyager 1. When it arrived in April 2013, it caused vibrations in the plasma surrounding the spacecraft. By measuring the frequency of those vibrations, scientists calculated that the density of the matter around the probe was 40 times thicker than the solar wind. This was the final, irrefutable proof. Voyager 1 had definitely exited the heliosphere and was now on its journey through interstellar space. The coincidental alignment of the magnetic field was just a strange quirk of the cosmos, reminding us that reality is always richer and more wondrous than any computer simulation. Now, as you lie relaxing, picture Voyager 1 silently journeying away from its home. Its signals now take over 16 hours to reach Earth, traveling across more than 20 billion kilometers. It is a tiny whisper from a place no human has ever been, telling of a border that isn't rigid, but a flexible, rippling membrane, constantly expanding and contracting with the breath of the Sun. The solar system doesn't have a sharp edge, but a soft skin that is constantly negotiating its territory with the vast interstellar medium. Voyager has passed through that skin, carrying all our curiosity and hope into the void. Let your mind drift like that ship, strolling through the interstellar ocean. We have together witnessed the historic moment when humanity officially stepped out of its own front door. In the next chapter, I will tell you about the mysterious humming sounds and the pressure waves that Voyager detected in interstellar space, a place we once thought was absolute silence. When we think of the space between the stars, our minds often conjure an image of absolute emptiness, a vacuum devoid of any sound or substance. However, the data from the two Voyager spacecraft has shown us a completely different reality. Interstellar space is not a void. It's more like a vast ocean, an ocean of charged particles and invisible magnetic fields. In August 2012, Voyager 1 officially entered this new territory, and one of the most startling discoveries was the sounds it captured. When scientists converted the plasma oscillations, a state of matter surrounding the craft, into sound waves audible to the human ear, the result was astounding. It wasn't a melodious symphony, but a high-pitched, persistent hum, like the sound of wind whistling through a narrow gap late at night. This ceaseless whisper is the sound of interstellar space, a reminder that even in the seemingly emptiest places of the universe, something always exists. These are scattered atoms, pressure waves that have traveled for millennia from distant supernovae or from the aftershocks sent out by our own sun. Voyager 1 discovered that, even after leaving the solar system, it could still feel the echoes from its parent star in the form of interstellar shockwaves. 6 years later, on November 5th, 2018, its twin, Voyager 2, followed in its sibling's footsteps into interstellar space. However, Voyager 2 carried a treasure that its older sibling no longer had in operation: a plasma detector that could directly measure the properties of the surrounding matter. Thanks to this instrument, we discovered a surprising secret. Previous theoretical models predicted that the interstellar medium would be relatively cold, with temperatures around a few thousand degrees. However, direct measurements from Voyager 2 showed that the plasma just on the other side of the boundary is much hotter than we thought, ranging from 30,000 to 50,000 degrees. Although its density is incredibly thin, this heat has completely changed how we understand the interaction between the solar system and the galaxy. The journey of the two spacecraft also revealed that the heliopause, the boundary separating the solar system from the outside, is not a solid wall. Voyager 2 detected layers of plasma leaking from the outside in, and vice versa. It's as if our heliosphere has holes, allowing for a quiet exchange of material between our home and the galactic ocean. This means that for billions of years, hydrogen and helium atoms from deep space have been slowly entering the solar system, perhaps contributing to the composition of the planets and even the seeds of life. The farther the Voyager probes travel from the Sun, the more the density of the plasma increases. This is another mystery that scientists are still working to explain. Something out there is compressing the interstellar material, creating a region of higher density as we venture deeper into the darkness. Could it be the bow wave created by our solar system as it moves through the galaxy at 23 kilometers per second? The answer still lies ahead, in the faint signals that the two spacecraft diligently send back every day. Besides the hum of the plasma, the instruments on board have also recorded galactic cosmic rays with extraordinary energy. These are atomic nuclei accelerated to nearly the speed of light from distant star explosions. They have traveled for millions of years before finding Voyager's tiny detectors. Each tiny particle tells a story of the violence of the cosmos, of the black holes or supernova remnants where they were born. Now, as you sink into relaxation, try to imagine the two Voyager probes as two explorers sailing on a dark ocean. Around them is not emptiness, but a symphony of energetic particles and magnetic fields. They are listening to the whispers of the galaxy, whispers that we humans have never heard in our millions of years of existence. The signals they send back, though having only the power of a refrigerator light bulb, are still traveling over 20 billion kilometers to tell us that out there, the universe is alive and full of wonders. We are not alone, for we have our courageous emissaries who are speaking with the stars on our behalf. In the next chapter, we will temporarily leave behind the dry measurements to look back at a photograph that forever changed how we see ourselves and our blue planet. It is the story of the pale blue dot. Throughout their long journey, the Voyager spacecraft have sent back countless pieces of invaluable scientific data, from the erupting volcanoes on the moon Io to the magnificent ice rings of Saturn. Yet, perhaps the most enduring and moving legacy Voyager left for humanity doesn't lie in dry numbers or complex geological findings. That legacy lies in a single perspective, an image that forever changed how we define our place in the vast cosmic ocean. Let's travel back in time with me to February 14th, 1990. At that time, Voyager 1 had completed its primary mission of exploring the giant planets and was about 6 billion kilometers from Earth. At that vast distance, the spacecraft was preparing to permanently shut down its cameras to save energy for its long journey into interstellar space. But before darkness fell upon its lens, astronomer Carl Sagan and his colleagues at NASA made a final, very special request. They commanded Voyager 1 to turn around and take one last look at the home it had left behind. The result of that command was a series of images called the Family Portrait of the Solar System. These were pictures of Venus, Earth, Jupiter, Saturn, Uranus, and Neptune, seen from the outermost edge of the Sun's kingdom. But among all those photos, one image became an icon, a profound philosophical statement about our existence. It is the pale blue dot. In that photograph, our Earth doesn't appear brilliant with white clouds or deep blue oceans like in photos taken from low orbit. From Voyager's distance of 6 billion kilometers, Earth is just a single, lonely speck, a faint pixel so indistinct it's hard to even recognize. It looks like a tiny mote of dust, suspended in a sunbeam that happened to catch the camera's lens. Looking at that tiny dot, astronomer Carl Sagan penned words from the heart that would later become an invaluable part of humanity's spiritual heritage. He invited us to look deeply at that tiny dot and realize, that's here, that's home, that's us. Try to imagine for a quiet moment that every person you have ever loved, every person you have ever known, every human being who ever lived and breathed on this planet has lived out their entire life on that tiny speck of dust. All the joys and sorrows, all the glorious achievements and bitter failures, all the wars and peace, the love poems and the symphonies, the heroes and villains, everything that has ever been a part of human history has unfolded on that tiny dot, suspended in a sunbeam. Sagan reminded us of the common arrogance of humans, the belief that we hold some privileged position in the vast universe. He spoke of the rivers of blood spilled by generals and emperors, just so they could become the temporary masters of a fraction of a speck of dust. The perspective from Voyager 1 taught us a profound lesson in humility. It reminds us of our responsibility to treat each other more kindly, to cherish and preserve that pale blue dot, because it is the only home we have ever known, the only refuge for life in the cold, cosmic ocean. The pale blue dot photograph is not just an unexpected byproduct of a scientific exploration program. It is a priceless gift that Voyager gave to humanity. It helps us realize that even though we can send ships to the far reaches of the solar system, in the end, everything we have is tied to that tiny and fragile dot. Now, as you relax in the peaceful darkness of your room, try to feel the small yet wondrous nature of the Earth. We are drifting together on a speck of dust in space, protected by a fragile atmosphere and warmed by an ordinary star. Voyager traveled far to show us the value of what is closest to us. That perspective continues to follow Voyager 1 as it ventures deeper into the darkness of the galaxy. The spacecraft is still flying farther away, moving a little more distant from its home with each passing second. It no longer has a camera to capture our image, but the memory of that pale blue dot has been forever etched into the consciousness of humanity. Voyager's journey has taught us that the universe may be too vast for us to fully comprehend, but it is our ability to recognize and question our own place within it that makes humanity extraordinary. We are the ones who look up at the stars and ask ourselves, who we are. This chapter closes with the image of a tiny speck of dust in a sunbeam, a symbol of peace and humility. In the final chapter, I will tell you about the last days of the mission, about the silent immortality of the two spacecraft, and the eternal message they will carry as they fly through the millennia ahead in the endless silence of interstellar space. The two spacecraft, Voyager 1 and Voyager 2, are still silently flying onward, carrying the last warmth of humanity into the heart of the galaxy. However, we must face the fact that time for these missions is running out. With each passing day, the energy source that powers the two spacecraft is gradually depleting, following an irreversible law of nature. The heart of each spacecraft is a generator that uses heat from the decay of plutonium-238. Since leaving the launch pad in the summer of 1977, these hearts have operated non-stop. However, over time, the amount of electrical power they generate steadily decreases, losing about 4 watts per year. In 2025, the Voyager 1 spacecraft will only be producing about 230 watts of electricity, less than half of the initial 470 watts it had when it first left Earth. To preserve their final breaths, engineers on Earth have had to make difficult decisions. They have gradually shut down the heaters that kept the components from freezing, and the cameras were disabled long ago because they consumed too much power. Currently, the spacecraft's fuel tanks are completely frozen, but since they only need to glide on inertia in a vacuum, this is still acceptable. Current forecasts indicate that around the year 2025 or 2026, the spacecraft will no longer have enough power to send back coherent scientific data. By 2030, the instruments will have to be shut down permanently, and around 2035, even the signal transmitter will fade into silence. At that point, the giant antennas of the deep space network on Earth will only hear silence from Voyager's direction. The two spacecraft, after transmitting signals non-stop for nearly 60 years, will finally become silent objects, drifting forever. However, that silence does not mean the journey is over. Voyager 1 will continue to hurtle forward at a speed of 17 kilometers per second, and Voyager 2 at 15 kilometers per second. Let's imagine a distant future, 40,000 years from now. 40,000 years, a span of time, as long as the entire journey from when we modern humans left Africa until today. By then, Voyager 1 will drift past a small red dwarf star named Gliese 445 in the constellation Camelopardalis. It will only pass at a distance of 1.5 light years, like a ship crossing an endless ocean with no port of call. At the same time, Voyager 2 will approach the star Ross 248 at a distance of nearly 2 light years. Both will pass these distant neighbors in absolute silence, as their transmitters will have fallen silent millennia before. Even though the electronics may fail, even though the signal is lost, Voyager still carries an immortal treasure, the Golden Record. Made of durable gold-plated copper, this record can survive and remain readable for the next 1 billion years. In that 1 billion years, the face of the Earth will have changed beyond recognition. Continents will shift, species will evolve and then go extinct, and the sun will grow brighter, possibly making our planet uninhabitable. Yet, somewhere in the galactic ocean, the music of Bach, of Mozart, and the laughter of Earth's children will still exist, intact on the Golden Record. The philosopher Carl Sagan once said that the Voyager spacecraft will be humanity's oldest artifacts. When our pyramids and cities have crumbled to dust, Voyager will still be drifting like a technological fossil, an eternal message to anyone who might find it in the distant future. It is a love letter to the cosmos, a declaration that there was once a tiny species on a pale blue dot that knew to ask questions about the stars and was brave enough to send a piece of its soul into the great unknown. Voyager's journey teaches us that this universe is vaster and more unforgiving than any simulation. But it is also a place full of perceivable wonders. The fact that we could build rudimentary tools in the 70s, using less memory than a modern wristwatch, yet still reach interstellar space, is a testament to the scope of human intellect. We may not be the strongest or the longest-lived species, but we are the ones who are always curious and never stop searching. Tonight, as you prepare to drift off to sleep, remember those two tiny spacecraft. On our behalf, they are exploring the darkest, coldest, and also most serene regions of the galaxy. Their legacy lies not just in dense data sets about hydrogen and helium, but in the hearts of every dreamer, in the eyes of children who look up at the night sky and wonder, what's out there? The grand journey of Voyager will continue forever, orbiting the center of the Milky Way in paths that last 200 million years. And we, the people living on a speck of dust suspended in a sunbeam, let us cherish every moment, cherish our only home, and continue to nurture the flame of curiosity that Voyager has ignited. Our story of the interstellar emissaries now comes to a close. Let the messages of peace and the sounds of Earth soothe your mind. Allow yourself to drift among the myriad stars, peaceful and light. Voyager's journey is eternal, and may your sleep be just as deep and peaceful. Sleep well.